Hello and welcome to yet another video on my channel on the topic group theory. So in this video we are going to prove that this set Z4 along with the operation addition modulo 4 is a cyclic group. First of all, let us write down the elements of Z4. So the elements of Z4 are 0, 1, 2, and 3, which correspond to the remainders when a particular number is divided by 4. Remainders upon division by 4, right? So these are the elements in our set structure Z4, and the operation addition modulo 4 is defined as follows. Let us say we have got an element A and another element B, which are from Z4. So the addition modulo 4 operation is going to be give us A plus B. This is the normal arithmetic addition modulo 4, which means that we take the arithmetic sum of A and B, and we divide it by 4, and further we look at the remainder, and the remainder is going to be the solution of the operation between A and B. So this is our group. Now let us check if there is an element which actually generates this particular group or not. So check if there exists an element X belongs to Z4 such that the group generated by X is equal to Z4. Right? So this means that, so this symbol over here means the group generated by X. Okay. Uh, since we need to prove that this is a cyclic group, if even if we identify one element, a single element X, it should be enough. So suppose that we let the value of X to be equal to 1. Now, let us see if the generated group of X is equal to Z4 or not. So in order to find the generated group, the group generated by X, we need to do the following. We have to repeatedly use the operation over between 1 and 1, and again with 1, again with 1, and so on. Okay, so let us assume that 1 plus 1, let us find out what 1 plus 1 is. So this would be 1 plus 1 modulo 4, that is same as, let us put a congruent symbol here, 2 modulo 4, that is same as 2. So hey, you know what, we started with 1 and we got 2. So 1 is an element, 2 is an element. Let's move on and let's try to see if 2 operated with 1 is also an element or not. Okay, so 2 plus 1 modulo 4, that is same as 3 modulo 4, and that is going to give us 3. 3 plus 1 is going to give us 3 plus 1 modulo 4, right? And that is going to be going to give us 4 modulo 4, and that is equivalent to 0. Therefore, what we can imply from here is the group generated by X contains X value, that is 1, and then we got 2, 3, and 0, which is exactly the same as Z4, right? Hence, we can conclude that G, which is equal to Z4, the group, is a cyclic group, right? Okay. All right. Now let us try to find all the generators, right? So the definition of a generator is as follows. Let us consider the definition of a generator. So a generator, a generator must produce all four elements, right? So what are the four elements? The four elements are 0, 1, 2, and 3. So let us try one by one all the possible elements that we have at our disposal. So if we consider 0 belongs to Z4, right? When 0 belongs to Z4, you'd observe that 0 operated with 0 is going to be 0 plus 0 modulo 4, that is going to be same as 0, right? So 0 is basically the idempotent element or the identity element. Hence 0 is not a generator, because however times you use this operation 0 on itself, you're going to get 0. We have seen, we have just seen, we have seen that the group generated by 1 is same as Z4. So 1 is generator, right? Okay. Let us try to identify if 2 is a generator or not. Okay, let us look at 2 belongs to Z4. So first, let's do 2 operated with 2. That gives us 2 plus 2 modulo 4. Now that is same as 4 modulo 4, and that gives us 0. And then we are back in square one, because the group generated by 2 contains just two elements, 2 and 0, and that is not equal to Z4. So 2 is not a generator. So we have checked for 0, 0 is not a generator, 1 is a generator, 2 is not a generator. Let us now check for 3, correct? So 3 belongs to Z4. Let us see, 3 operated with 3 would give us 3 plus 3 modulo 4. Now 3 plus 3 is 6, and 6 modulo 4 is 2. The resultant will be again operated with 3, because 3 is the generator, correct? So we get 2 plus 3 modulo 4. The arithmetic sum of 2 and 3 is 5. 5 modulo 4 is going to be 1. And then finally we operate 1 with 3, because 3 is the generator. 3 is, we are trying to see if 3 is the generator of the group, right? So 1 plus 3 modulo 4 is the value over here. 1 plus 3 is 4. 4 modulo 4 is 0. So what do we get here is the generator of 3 containing 3 itself. We get the 2 value from here, right? We get the 2 from there. Okay. Further, we get the 1 from here. So 1. And finally, we get the 0, right? So 0. This is same as Z4. Therefore, 3 is a generator. Okay, now the final answer is as follows. The generators of Z4 are 1 and 3. Hey, by the way, there is a little shortcut method to find out the generators of 4. Okay, so let us write that down as well. Now, we say that A is a generator of Zn, right, comma, plus n, if GCD of A and N is equal to 1. That is, A and N are coprime. Now, can we use this definition or this lemma or this theorem to find out the generators of Z4? So in Z4, comma, plus 4, we have N as equal to 4. Now, we observe the following. GCD of 1 and 4 is equal to 1, and GCD of 3 and 4 is equal to 1 also. Therefore, generators are equal to 1 and 3. Hey guys, thanks for watching. Hope you like the video.